Again, we are back here with our online classes. Now, before we start with our online classes, let me discuss about the chapters which we have built in offline classes. The first chapter and the second chapter we have already completed. The second chapter is related with the physical quantities and measurement, about the density, about the mass, relative density, all these things we have discussed it. Okay, and now today we will start with a new chapter, that is force and pressure. Now we will discuss two things today. One is a force and other one is the moment of force. Okay. Now the force, the term force, which is it's a very common word which we use in our day-to-day activities, in different situations. We use the term force, we apply the term force. To perform a various work, we use force. To play games, okay, like to kick a football, okay, to run, to do your work. So all these activities, force is needed. And this force is a very common word which we use in our day-to-day life. Without force, you cannot make a body in motion, in which the body is in a state of rest, you cannot make in a state of motion, or you cannot make that moving body to stop if you don't apply force. So force will make a body in motion. Either the body can move or the moving body can stop. So this is done by force. So therefore, when we define force, force is a pull or push. It is a pull or push which tends to change or which changes the state of rest or a uniform motion. Okay, which means that the force can make a body to bring in the state of rest. The moving body can stop, or you can bring in the state of rest by applying a force. Or when a body is in the state of rest, you can bring that body or you can make that body in motion by applying force. So force makes the body either to move or to stop. So therefore, force is a pull or push, we call it. And the unit of force, the SI unit of force is Newton. The SI unit of force is Newton. Okay, SI means the System International Unit. And the CGS unit of force is dyne. D-Y-N-E, dyne. SI unit of force is Newton. CGS unit of force is dyne. Okay. And there is a relation between the CGS and the SI unit of force. So CGS unit and SI unit of force means 1 Newton is equals to 10 to the power of 5 dyne. 1 Newton equals to 10 to the power of 5 dyne. So how it comes is that, now let us, before we come to the relation, let us discuss about the term Newton. Okay. So now to calculate force, there is a relation here. Force equals to mass into acceleration. F equals to m into a. F means the force, mass is the kilogram, the SI unit of mass is kilogram, and SI unit of acceleration is meter per second square. Okay, mass means the matter contained in the body. Acceleration is the rate of change of velocity, and acceleration is also known as increasing velocity. Okay. Now to find the force, we will use this relation F equals to m into a. Now let us define Newton. Since the SI unit of force is Newton, okay. Now let us define Newton. How will you define Newton? So define Newton. First I will write it, the unit of force, unit of mass, and unit of acceleration. So unit of force I will write it here, Newton. The SI unit of force is Newton, written as capital letter N. Okay, since this unit is kept after the name of a scientist, So therefore, the unit is always expressed or written in capital letter. Okay. Now F equals to Newton. This is which is the SI of the force, and N is the kilogram, kg. Okay, and A is acceleration, which is written as meter per second square. The SI unit of acceleration is meter per second square. Now I'll write it here 1 Newton, 1 kilogram, and 1 meter per second square. That means this relation has come from this F equals to M into A. Now you can define Newton. Newton means 1 Newton is the force which acts on a body of mass 1 kilogram, which produces the acceleration of 1 meter per second square. That means define Newton. If it comes, define Newton. So how do you define Newton? A very simple way to define Newton from the relation. 1 Newton is the force which acts on a body of mass 1 kilogram, produces an acceleration of 1 meter per second square. So this is 1 Newton. So definition of Newton you can define it this way. Okay. Similarly, you can define dyne also. Okay. So dyne, the CGS unit of force is dyne. The CGS unit of mass is gram. The CGS unit of acceleration is centimeter per second square. So I write it here 1 dyne, 1 gram, 1 centimeter per second square. Now you can define dyne also. So define dyne. If it comes, how you define? 1 dyne is the force, because dyne and Newton both are force. Okay. So therefore 1 dyne is the force which acts on a mass of 1 gram, produces an acceleration of 1 centimeter per second square. So this is the definition of dyne. So you can define dyne and Newton from the relation F equals to M into A. Okay. Now the relation. Now the next one is relation between the Newton and a dyne. So what is the relation between the Newton and a dyne? Now 1 Newton, again I write the same thing. 1 kilogram into 1 meter per second square. Now 1 Newton, I'll keep it as it is. Okay. Now I'll convert this kilogram into gram. To convert kilogram into gram, I am multiplying by 1 into, I will write it 1 here only. To convert kilogram into gram, I will multiply by 1000. Okay. Then convert this meter into centimeter. To convert meter into centimeter, I will multiply by 100 here. Okay. 100 centimeter makes 1 meter. Okay. And the seconds will remain same. Time will remain same both in CGS unit as well as SI unit. In SI unit, the time will remain in seconds. Okay, the time will not change. In CGS unit also, the time will be in second, and in SI unit also the time will remain in second. So no need to change time. That is, it remains as it is in second. Now 1 Newton equals to, just multiply here. This is gram. Okay, 1000 gram into 100 centimeter per second square. Okay, then 1, 2, 3, 4, 5 zeros are there. So what I can write here? 10 to the power of 5 I can write. Gram I can write. Centimeter per second square. So 10 to the power of 5 gram centimeter per second square. So 10 to the power of 5. Look at here. Gram centimeter per second square is equivalent to dyne. So therefore, what I can write it here is that 1 Newton equals to 10 to the power of 5. Instead of writing this gram centimeter per second square, gram centimeter per second square is equivalent to dyne. So I'll write it here 10 to the power of 5 dyne. So this is the relation between the CGS unit of force and the SI unit of force. So therefore, if you derive this, you can derive this way. Okay. That means from the relation this 1 Newton equals to 1 kilogram into 1 meter per second square has come from this relation F equals to M into A. Just change the mass here from kilogram converted to gram, from meter converted to centimeter. Okay, and finally this will come as 10 to the power of 5 gram centimeter per second square, and it is equivalent to 10 to the power of 5 times. So 1 Newton equals to 10 to the power of 5 dyne. Okay, so this is the relation between the CGS and SI unit of force. Okay, now after that we'll come to the next point, moment of force. Okay, so before we come to the moment of force, let us discuss about the translational motion. Okay, first we discuss about the translational motion. Now, if a body is free to move, if a body is rigid is very strong, but free to move, when we apply the force on that rigid body which are free to move, the body will move in the direction of the applied force. Okay. Example I will give you. Suppose you take a table. You push a table towards other side. That means you apply the force on the. If you want to make that table to move, you have to apply the force. The table is rigid, strong, but the table is free to move. When you apply the force on the table will move in the direction where you are applying the force. Suppose if I am pushing the table forward, the table will move forward because I am applying the force in the forward direction, the table will also move in the forward direction. If I pull the table towards me, that is backward, the table will also move towards backward. So that means whichever direction you apply the force, the body will move in the direction of the applied force. So, when the force is applied on a rigid body which is free to move, the body will move in the direction of the applied force, that the body will travel in a straight line, and that force we call it, that motion we call it as a translational motion. Okay, we call it as a translational motion. The example, you just think over an example of pushing a table. When you push the table will move in the direction of the force and it will move in a straight line. Okay, so that is the translational motion. But the next point is here, if a body is rigid but not free to move, the body is not free to move. And why the body is not free to move is that because the body is pivoted. Pivoted means the body is fixed. Let us consider one body. Okay, you take a wooden scale or a plastic scale. Now this wooden scale or plastic scale, what you do, you just fix at the middle way, at the center with the help of a nail. You fix a nail in such a way so that this scale can rotate in two directions, clockwise direction as well as anti-clockwise direction. That means if a body is rigid but not free to move, the body will not have or not produce translational motion. The body will not be able to move freely. The body will not be able to travel in a straight line. Since the body is pivoted or the body is fixed. Pivoted means fixed. Okay. So when the body is pivoted, the body will not have a translational motion, but when the force is applied on that body, the body will have rotational motion. The body will have got rotational motion. And that force, when we apply the force on that body, which is pivoted, which is fixed, the body will not have translational motion, the body will have got a rotational motion, then that body will rotate in two directions. The body can rotate in a clockwise direction as well as in a anti-clockwise direction. So that we call it as a moment of force. Okay, so now this body will have, instead of moving in a straight line, instead of having a translational motion, the body will have a rotational motion. And to produce a rotational motion, the body has to be pivoted. The body has to be fixed at one point. When the body is fixed at one point, then the body will have a rotational motion. This body will produce a turning effect, and that turning effect of force we call it as a moment of force, or simply we call it as a moment. Example, closing and opening of door. Okay, now the door is pivoted. The door is pivoted means the door is fixed at one point, and the point where the door is fixed is hinge. X-I-N-G-E. Hinge is a point where the door is fixed, and the door will move around. They will have a rotational effect or rotational motion the door will produce around the hinge. Okay, you can close the door, you can open the door, and this closing and opening of door will produce a rotational effect, or it will produce a moment of force within the hinge. But if you remove that hinge, what will happen? The door will fall, it will come down. the door will not remain fixed, because the door is fixed because of the hinge which has been pivoted at the two ends of the door. Okay, so this produces moment of force, that we call it as a moment of force. Okay, so in the next class we will come to the some technical terms which are related with the moment of force. Thank you.